Stars have fascinated mankind forever. They have influenced religion and exploration. It is said that astronomy is likely to have developed even before language and is our earliest science. But what do we know about stars and where they come from? In the beginning, there was only energy, and then the Big Bang happened, giving substance what became an endless expanding universe of time, space, and matter. So what is our universe like now, some 13.8 billion years after this Big Bang? We can see that in space there are an enormous number of stars even with the naked eye. Each of the stars you see in the night sky is a luminous sphere of superheated gas. It was formed when interstellar matter gathered in clumps, each of which condensed into a dense mass that started to burn hydrogen, starting the star's life cycle. Astronomers have discovered that these stars are grouped into vast conglomerations we call galaxies. Indeed, many of the stars we can see are actually whole galaxies made of billions of stars. It's been estimated that there are up to 500 billion separate galaxies in our universe. Scientists have yearned to understand the complexity and enormity of the cosmos, starting with our solar system. Aristotle around 340 BC believed that the Earth was the center of the universe, surrounded by concentric celestial spheres of planets and stars, possessing layers much like an onion. Stars were fixed in outer layers with the planets in the moving inner layers. Ptolemy, around 100 AD, refined this geocentric theory further, with the planets performing their own epicycles as they circled the Earth. Using this, he could predict the whereabouts of any planet surprisingly accurately. This is why his model was accepted for the following 1,300 years. Copernicus, in the 16th century, was the first to propose a heliocentric model where the planets, including Earth, revolved around the Sun. He still believed the stars to be stationary beyond the solar system. Newton improved our understanding of the cosmos with his theory of universal gravitation, in which all the celestial objects attracted each other with force according to their masses and inversely according to their square of their distance apart. He used this to accurately show how the planets circle our massive sun in elliptical orbits. For most, the magnitude of stars, galaxies, and the universe is incomprehensible. The sun is 1,300,000 times larger than Earth. But our sun is only a medium-sized star. Sirius A is twice as big as our star, while Rigel is 70 times larger. VY Canis Majoris is one of the largest stars in our galaxy, and is 1,500 times bigger than the Sun. Remember, there are at least 200 billion such stars in our galaxy, and our Milky Way is only one of uncountable billions of separate galaxies, most of them invisible to us, or so far away they appear to our eyes as a single star. Stars come in many different colors. Different wavelengths of light are perceived as different colors, and the emitted wavelength of stars varies with its temperature. Cooler stars radiate in the red area of the spectrum, and hotter stars radiate towards the blue end. These factors explain the diversity of the colors of the stars across the universe. Red stars are the coolest at roughly 3,000 degrees Kelvin. Yellow and white stars are increasingly hot, while blue stars are the hottest at roughly 25,000 degrees Kelvin. Temperature and luminosity or brightness allows us to classify stars. Hertzsprung-Russell diagrams plot a star's luminosity against its temperature. Blue high-energy stars occupy the top left, and red high-energy stars occupy the top right. Lower energy stars are situated towards the bottom. The vast majority of stars lie in the middle of the diagram, on what is known as the main sequence, which are medium-sized stars. The HR diagram is dynamic, with stars moving across it throughout their life cycles. Like all good things, the life of a star must come to an end, and it can happen in a spectacular light show. As the star runs out of nuclear fuel, some of its mass flows into its core. Eventually, the core is so heavy that it cannot withstand the gravitational force. The core collapses, which results in the giant explosion of a supernova. A supernova scatters elements across the cosmos, which may eventually start to form into new planets and stars. And so the cycle begins again.